All right, so today we are going deep on AWS.
Amazon Web Services.
Amazon Web Services, that's right.
Yeah.
It's funny, I was looking through all the notes and questions that you sent over, and it seems like you are about to jump into some sort of project.
Yeah, could be.
Maybe a big project, maybe just trying to get up to
You
speed,
wrap their head around it, yeah.
wrap your head around the cloud and all that it entails. And, I have to admit, I saw VPC mentioned quite a bit in your notes.
Yeah, definitely.
It seems like it's a pretty fundamental concept when it comes to AWS.
It's the foundation of everything, really.
Yeah.
So a VPC stands for Virtual Private Cloud, and you can kind of think of it like your own little private internet inside of AWS.
Oh, okay.
You define your own network, you set up subnets, which are kind of like subnetworks, and you control how traffic flows in and out through things called gateways.
So it's kind of like building your own world, your own little internet.
Yeah, like a walled garden.
Yeah, a walled garden inside of AWS.
Yeah, exactly.
I like that.
So, yeah, it's all about having that kind of control and isolation for your cloud resources.
Now, speaking of control, my notes also mentioned something about safeguarding EC2 instances.
Right.
And I have to admit, security is a big concern for me when I think about the cloud in general.
Absolutely. And AWS takes security very seriously.
Yeah.
They have a layered approach, and it starts with understanding the difference between security groups and network ACLs, which sound very similar, but are actually quite different.
Okay, so security groups versus network ACLs.
Right.
Break it down for me. What's the difference?
So think of security groups like a really strict bouncer standing in front of each of your EC2 instances.
Okay.
They scrutinize every single connection that tries to come in or go out.
Wow, tough bouncer.
Very tough bouncer. They only let traffic through that meets very specific rules that you set.
Got it.
So you're in complete control of what's allowed in and out at the instance level.
That makes sense. Very granular control.
Very granular.
So then what are network ACLs for? It almost sounds like they do the same thing.
They do work together, but at a higher level.
Okay.
So imagine network ACLs as a wall surrounding your entire subnet, like the city walls.
The city walls, okay.
Yeah, so before traffic even gets to your instances, it has to pass through these network ACLs.
I see.
You might use them to block traffic from certain IP addresses or protocols.
So it's like a first line of defense.
Exactly, a first line of defense.
So we have our city walls, and then we have our bouncers at the door.
You got it.
2 layers of security.
That's the idea.
That's great. I love that analogy.
Chock full of them.
Okay, so we talked about VPCs, we've talked about security, and my notes also mentioned this thing called VPC peering.
Right.
And it seems like it has something to do with connecting different VPCs together.
It does.
Well, why would you want to do that? What's the advantage of connecting these separate little networks?
So imagine you have one VPC for your development environment
Okay.
and another one for your production environment.
Okay.
You want them to be able to talk to each other. But you also want to keep them somewhat isolated.
Right.
VPC peering lets you do that.
Oh, interesting.
It creates a secure connection between them, allowing traffic to flow freely while still maintaining that separation.
So it's like building a bridge between those two worlds.
Yeah, like a secure bridge.
I like that. Okay.
Yeah, and what's really cool is that you can even peer VPCs that belong to different AWS accounts.
Wait a minute. So I can connect my cloud network to somebody else's cloud network
You can.
securely.
Securely.
Wow.
It's pretty powerful stuff.
Yeah, that opens up a lot of possibilities.
It does, especially for businesses that are collaborating on projects or need to manage complex environments with multiple accounts.
Yeah, I'm starting to see why you called VPCs the foundation.
It all builds from there.
It all builds from there. Absolutely.
Yeah.
Okay, so we've got our VPCs set up. We've got our security in place. Now let's talk about these EC2 instances I keep seeing pop up.
All right.
My notes are a little vague on what they actually are.
Sure. So EC2 stands for Elastic Compute Cloud, and it's essentially how you get virtual servers in the cloud.
Oh.
So if you need a server, you spin up an EC2 instance.
So it's like renting a server in the cloud.
Exactly.
And the elastic part, I'm guessing that has something to do with scalability.
It's all about scalability.
Yeah.
You can easily adjust your compute resources as needed.
Perfect.
So if you have a sudden spike in traffic, you can just launch more instances.
Wow.
And when things quiet down, you can spin them back down and you only pay for what you use.
That's the beauty of the cloud, right?
That's the beauty of the cloud.
This whole on-demand scalability.
Exactly.
I love it. No, my notes also mention AMIs.
Right.
And it seems like they're pretty important in this whole EC2 world.
They are.
What exactly are AMIs?
So AMI stand for Amazon Machine Images, and they're basically templates for your EC2 instances.
Okay.
They define the operating system, the software, all the pre-configured settings.
Got it.
You can choose from a huge library of pre-built AMIs, or you can even create your own custom ones.
So it's like picking a pre-made server configuration instead of having to build everything from scratch.
Exactly. It saves you a ton of time and effort,
That makes sense.
and it ensures consistency across your instances.
Now, I'm also seeing notes about stopping and terminating instances.
Right.
And there seems to be a pretty important difference between the two.
There is. It's a critical distinction.
What's the deal?
Think of stopping an instance like hitting the pause button.
Okay.
The instance goes into a suspended state,
Okay.
but your data on the attached EBS volume, that stays intact.
Okay.
So you can restart the instance later and pick up right where you left off.
So it's like pausing a movie.
Yeah, exactly.
Got it. So then why is terminating different?
Terminating is more like hitting the delete button.
Oh, okay.
The instance is gone permanently,
Wow.
and any data that wasn't stored elsewhere is gone too.
So that's a pretty big deal.
It is. You got to be careful.
Yeah, you don't want to accidentally terminate an instance and lose all your data.
That'd be bad.
So if I'm just taking a break,
Stop the instance.
stop the instance,
If you're completely done with it,
terminate it.
terminate it.
Got it. Okay, so we've talked about stopping, we've talked about terminating. My notes also mention key pairs quite a bit,
Right.
and it sounds like they're really important for security, but I have to admit, I'm not entirely sure how they work.
So key pairs are like digital keys that give you secure access to your EC2 instances.
Okay.
You generate a pair of keys, a public key and a private key.
Okay.
The public key is stored on AWS,
Got it.
and the private key you download and keep safe.
Okay.
When you want to connect to your instance, you use that private key to authenticate.
So it's like a two-factor authentication system.
That's a good way to think about it.
Okay. And just like with physical keys, if you lose your private key,
You're locked out.
you're locked out, there's no getting back in.
No backdoor, no master key.
So keep those keys safe.
Very safe.
I will.
All right, good.
Seems like security is a recurring theme when it comes to AWS.
It's paramount for sure.
And for good reason. All right, so we've covered EC2, we've talked about AMIs, we've talked about key pairs.
We're making progress.
We're making progress, but there's still so much more to explore.
There is. We haven't even scratched the surface of storage yet.
Oh yeah, my notes are packed with questions about S3.
S3, the simple storage
The
service.
simple storage service.
It's where things get really interesting.
All right, well, let's dive into that then. I'm ready.
Let's do it. So S3 is like having this massive hard drive in the cloud.
Okay.
You can store practically any amount of
Yeah.
data.
I can imagine. And it's used for everything, right?
Everything, websites, backups, big data analytics, you name it.
That's amazing. But with so much data being stored in S3, how does AWS ensure that it's secure and reliable?
Right, so data loss is a huge concern for anyone.
Absolutely.
And that's where AWS's focus on durability and redundancy comes in big time. So when you store data in S3, it's not just sitting on a single server in some random data center.
Okay.
It's replicated across multiple availability zones.
Availability zones, what are those?
So these are basically separate data centers, physically separate,
Oh,
spread out geographically. So even if one entire availability zone goes down,
wow.
your data is still safe and accessible.
So it's like having multiple backup copies of your data in different locations.
Exactly. It's all about redundancy.
That's really reassuring. I mean, I'm starting to feel more comfortable with the idea of storing my data in the cloud.
It's designed to be incredibly reliable.
Now, my notes also mention different storage classes within S3.
Right.
Why would you need different classes of storage?
So not all data is created equal.
Okay.
Some data you need to access frequently, like active website files or, applications that are constantly being used.
Makes sense.
So that's where the standard storage class comes in.
Okay.
It's optimized for high performance, low latency.
Yeah.
You need to get to that data fast.
Yeah, got to be snappy.
Exactly. But then what about data that you don't need to access as often?
Like archives, right?
Exactly. Archives, backups, things like that.
Okay.
You don't need instant access.
Yeah.
That's where storage classes like Glacier come in.
Glacier, I've heard of that.
It's designed for long-term storage, very cost-effective.
I like the sound of that.
But retrieving data from Glacier takes a bit longer.
So it's like a trade-off, right?
Yeah. Lower cost, slightly slower retrieval.
Makes sense. You choose the storage class based on how often you need to access the data and how much you're willing to pay for speed.
Exactly.
Okay, that's clear. Now, my notes also mention EBS.
EBS, Elastic Block Storage.
Elastic block storage, another storage option.
Right, but this one's specifically designed for EC2 instances.
Ah, so it's like giving your virtual servers their own dedicated hard drives.
You got it.
Okay, but why would you need that if you already have S3?
Good question. So think of it this way. S3 is like a massive shared storage pool.
Okay.
perfect for storing objects and files. EBS is more like attaching an external hard drive directly to your EC2 instance.
Oh,
It
okay.
provides persistent block storage,
Persistent meaning.
meaning the data remains even if you stop or restart your instance.
Oh, that's important.
It is
So if I have an application that needs its own dedicated storage space,
separate from the shared S3 pool.
yeah, then I'd use EBS.
Exactly.
And the storage persists even if my instance is temporarily offline.
That's right.
That's great. So we have S3 for general object storage, EBS,
Mhm.
for instance, specific persistent storage. I'm starting to see how all these storage pieces fit together.
It's a comprehensive storage ecosystem.
It is. And my notes also mention this term elasticity quite a bit.
Right.
We touched on it with EC2, but it seems like it's a broader concept in AWS.
It is. Elasticity is one of the core principles of AWS,
Okay.
and it goes beyond just compute resources. It's the ability to scale your resources up or down as needed, dynamically and automatically.
So it's not just about spinning up more servers when you need them.
It's about adjusting all sorts of resources on the fly.
Okay. To meet changing demands.
Exactly. Think about a website that experiences sudden spikes in traffic.
Like during a flash sale or something.
Exactly. A flash sale or a major news event.
Yeah.
Without elasticity, that website could easily get overwhelmed and crash.
That makes sense, but how does AWS actually achieve this elasticity?
So AWS provides a range of services and features that automate this whole scaling process.
Okay.
One example is auto-scaling.
Auto-scaling.
You can automatically launch or terminate EC2 instances based on predefined metrics,
Interesting.
like CPU usage or network traffic.
So if my website starts getting slammed with traffic
Auto-scaling can kick in.
and spin up more instances to handle the load
Exactly, and once that traffic subsides, it scales back down.
to save resources.
Exactly, you only pay for what you need.
It's like having an army of servers on standby ready to be deployed at a moment's notice.
That's a great way to put it.
I like that. And it's not just about EC2 instances, right?
Not at all. Auto-scaling can be applied to other AWS services,
Right.
like load balancers.
Load balancers, what do those do?
Think of a load balancer as a traffic cop,
Okay.
directing incoming requests to multiple servers.
Okay.
Helps distribute the load evenly.
So if one server starts to get bogged down, the load balancer can redirect traffic to other less busy servers.
That's exactly right.
smart.
And they can also do health checks on your servers.
Oh, really?
Yeah, they can automatically remove unhealthy instances from the pool
Oh, wow.
and redirect traffic to the healthy ones.
That's amazing.
It's all about resilience and scalability.
Load balancers are like the unsung heroes of the cloud,
They are working tirelessly behind the scenes.
keeping everything running smoothly.
Exactly.
Okay, elasticity, auto-scaling, load balancing, these all seem like essential tools for managing a dynamic cloud environment.
They are, and they all work together.
Now, my notes also mention something called cloud formation,
Right, CloudFormation.
and I'm not quite sure what it does or how it fits into this picture.
So CloudFormation is a powerful service that lets you define your entire AWS infrastructure as code.
Infrastructure as code, what does that mean?
It means instead of manually clicking around in the AWS console,
Right.
you can write code that describes your resources, their configurations, and their relationships.
So it's like writing a script that tells AWS exactly how to build your cloud environment.
Exactly.
Interesting.
And this infrastructure as code approach has a lot of benefits.
Like what?
First of all, it makes your infrastructure repeatable and consistent.
Okay.
You can easily spin up identical environments for testing development or even disaster recovery.
That's amazing. No more manual configuration headaches.
No more clicking around.
Right.
It's all automated.
I love it.
And it also makes your infrastructure more manageable.
In what way?
You can track changes over time, roll back to previous versions if you need to,
Oh, okay.
and even automate the entire deployment process.
So CloudFormation brings a level of automation and control to infrastructure management that would be really tough to achieve manually.
It does.
It's like having a blueprint for your entire cloud setup.
That's a great way to put it.
Okay, so we've got our VPC, our EC2, our S3. Now we're automating everything with CloudFormation. This is incredible.
It's all coming together.
It is, but my notes also mention several AWS services related to messaging and notifications.
Right.
There's a whole section on SNS, SQS, and SES.
Those are the big ones.
I'm guessing these are tools for communication within and between applications.
Exactly. They're all about communication in the cloud.
All right, break it down for me. What are the key differences?
So let's start with SNS.
Simple notification service.
It's a messaging service that allows you to send messages to a wide range of subscribers.
Oh, okay. Like,
Email addresses, mobile devices, even other AWS services.
so I could use SNS to send out alerts to my team if there's a problem with their application,
Absolutely.
or maybe even send marketing messages to our customers.
You could do that too. It's a very flexible and scalable platform.
I'm liking the sound of this.
And then you have SQS.
Simple queue service.
Simple queue service. This one's a little different.
My notes say it's a message queue. What does that mean in practice?
So a message queue acts as a temporary storage buffer for messages.
Okay.
Imagine you have different parts of your application that need to talk to each other.
Right.
Instead of having them talk directly, you can use SQS to send messages asynchronously.
Asynchronously. So one part of the application can send a message to the queue and another part can pick it up and process it later, even if the sender is offline.
Exactly. It's a way to decouple different components,
Okay.
which improves reliability and scalability.
So it's like a middleman for your application components.
It's like a reliable postal service.
I like that. Okay, so SNS for broadcasting messages, SQS for reliable queuing, and what about SES?
SES, simple email service.
Simple email server. That one sounds pretty self-explanatory.
It is. It's for sending email, but it's not your average email provider.
Okay.
SES is designed for high-volume, reliable email sending.
So if my business relies heavily on email communication.
SES would be a good option.
Okay, so SNS for broadcasting messages, SQS for reliable queuing, and SES for managing email. It's amazing how many different communication tools AWS provides.
It's all about giving you the options you need.
Now, my notes also highlight some services that aren't acronyms. IAM, KMS, and CloudTrail.
Right.
What role do they play?
These are critical services related to security, compliance, and overall management of your AWS environment.
Sounds important.
Let's start with IAM, which stands for Identity and Access Management.
Okay, IAM, Identity and Access Management.
That's it.
My notes say it's about controlling access.
Right.
Does that mean it's about setting up user accounts and permissions?
Exactly.
Okay.
IAM allows you to create users, groups, and roles, and then define granular permissions for each.
Granular meaning?
Meaning you can control who has access to which AWS resources, what actions they can perform,
Oh, wow.
even limit their access to specific timeframes or IP addresses.
So if I have a team of developers working on different parts of our application, I can use IAM to ensure that each developer only has access to the resources they need.
Exactly. That's the idea.
Okay, and why is that important?
It's all about the principle of least privilege.
Principle of least privilege. Never heard of that.
It means granting users only the minimum level of access necessary to do their jobs.
Oh, okay.
It's a fundamental security best practice.
That makes a lot of sense. So no one has more access than they absolutely need.
Right. You minimize the risk of accidental or malicious actions.
What about KMS? My notes say it's about managing encryption keys.
KMS, or Key Management Service, is a secure and centralized way to create, store, and manage encryption keys.
Encryption is a big deal, right? Especially in the cloud.
It is.
So instead of managing my own encryption keys, which could be risky, I can use KMS to handle all that complexity.
Exactly.
That's great. So KMS makes it easy to encrypt your data at rest, whether it's stored in S3, EBS volumes, or other AWS services.
Right.
It integrates seamlessly with other AWS services,
It does.
providing a comprehensive encryption solution.
That's the goal.
So IAM for controlling access, KMS for managing encryption keys. What about CloudTrail?
CloudTrail is like a security camera for your AWS account.
Oh, interesting analogy.
It logs all API calls made by users, applications, or even AWS services themselves.
So it's a record of everything that happens in my AWS environment.
Pretty much, yeah.
That sounds incredibly valuable for security auditing and compliance.
It is.
So I can use CloudTrail to track user activity, monitor API usage, and even detect unusual or unauthorized actions.
Exactly.
It's an essential tool for maintaining security and accountability in the cloud.
Absolutely.
IAM for controlling access, KMS for managing encryption keys, and CloudTrail for monitoring activity. It sounds like AWS has thought of just about everything when it comes to security and management.
Security is a top priority for them.
And for good reason.
Right.
But managing a cloud environment isn't just about security.
It's about data.
It's about data.
What you do with it.
What you do with it, and specifically what you do with that data. My notes also mentioned quite a few AWS services related to databases and analytics.
Ah, yes. Databases, the heart of many applications.
Databases and analytics, that's where the real power of the cloud comes in, right? I mean, what's the point of all this storage and compute power if you can't actually extract insights from your data?
You hit the nail on the head, and AWS offers a whole buffet of services to help you do just that.
A buffet, you say, well, I'm hungry for knowledge.
Great, because your notes specifically mention RDS, DynamoDB, and Redshift. Looks like you've done some homework already.
Well, I've definitely come across those names, but I'm still a bit fuzzy on the differences between them and when you would choose one over the other.
I hear ya.
So let's start with RDS, Relational Database Service. My notes say it's the go-to for, well, relational databases, but isn't that a bit old school in the age of NoSQL and big data?
Not at all. Relational databases are still incredibly relevant, especially for applications that need strong data consistency and ACD properties.
The city properties, now there's a term I haven't heard in a while.
Yeah, it stands for atomicity, consistency, isolation, durability. Basically guarantees that your database transactions are processed reliably.
Oh, right, like all or nothing, no half-finished transactions.
Exactly, and RDS makes it easy to set up, manage, and scale relational databases in the cloud with those guarantees in place.
So if I'm comfortable with those traditional databases like MySQL or PostgreSQL, I can easily migrate them to RDS and let AWS handle all the infrastructure management.
You got it. You get all the benefits of a managed database service, automated backups, software patching, high availability, all without the hassle of managing the underlying hardware and operating systems.
That sounds like a dream come true for any database administrator.
It's pretty sweet. But what about DynamoDB? Your notes mention it's a NoSQL database, and I have to admit the whole NoSQL world is still kind of a mystery to me.
Yeah, NoSQL, it's like this buzzword that gets thrown around a lot, but I'm not always sure what it actually means in practice.
Well, NoSQL databases like DynamoDB are designed for a different set of use cases. They excel at handling massive amounts of unstructured data, providing high scalability and low latency. Think of things like social media platforms, e-commerce sites that generate huge volumes of data with varying structures.
So if I'm building an application that needs to handle millions of users and their ever-changing data, DynamoDB might be a better fit than a traditional relational database.
It's often the preferred choice for those scenarios, and DynamoDB is fully managed, so you don't have to worry about provisioning servers or scaling the database manually. AWS handles all that for you.
Okay, so RDS for structured data with ACID properties, DynamoDB for flexible, high-volume, unstructured data. Got it. But what about Redshift? My notes mention it in the context of data warehousing and analytics. How does it fit into this whole database landscape?
Redshift is in a category of its own. It's a data warehousing service designed specifically for large-scale data analytics. Think about businesses that have petabytes of historical data that they need to analyze to gain insights, identify trends, and make better decisions.
Petabytes. That's a mind-boggling amount of data. Can traditional databases even handle that kind of volume?
They can struggle, especially when it comes to performance. Redshift, on the other hand, is optimized for analytical queries. It uses a columnar storage format, which means the data is stored by column rather than by row. This makes it incredibly efficient for querying large data sets and performing complex aggregations.
So if I'm running a business intelligence team that needs to crunch massive data sets to find insights, Redshift would be the ideal tool for the job.
It's a powerful solution for data warehousing and analytics, especially for businesses that need to scale their analytics capabilities as their data grows.
RDS, DynamoDB, Redshift, these are all powerful tools for managing and analyzing data in the cloud. But my notes also mention a few other services, Athena, eArm, and Kinesis. Where do those fit into the picture?
Those are all part of AWS's broader analytics ecosystem.
Okay, so we're going even deeper down the rabbit hole.
Exactly. So let's start with Athena, which is a serverless query service that lets you analyze data directly in S3.
Serverless, so I don't even need to set up a dedicated database server.
Nope, that's the beauty of it. You just point Athena at your S3 buckets, specify the data format, and start querying using standard SQL.
That sounds almost too easy.
It's pretty slick, and then there's EMR.
EMR, Elastic MapReduce, what is that all about?
It's a managed Hadoop framework.
Hadoop, now that's a name I haven't heard in a while.
Yeah, it's a powerful open source technology for distributed processing of large data sets.
So if I need to run complex, big data jobs, I can use EMR to spin up a Hadoop cluster in the cloud, process my data, and then spin it back down when I'm done.
That's the idea. EMR takes care of all the infrastructure management, allowing you to focus on writing your data processing code. And then there's Kinesis.
Kinesis, that rings a bell.
It's a streaming data platform.
Streaming data, that's data that's constantly being generated, like sensor readings or social media feeds, right?
You get it. Kinesis allows you to ingest, process, and analyze those data streams in real time.
So I could use Kinesis to build a dashboard that tracks real-time website traffic or monitors social media sentiment.
Those are just a couple of examples. Kinesis is incredibly versatile and can be used for a wide range of real-time data processing applications.
Wow, we've covered a lot of ground in this database and analytics deep dive. It's clear that AWS has a solution for just about every data challenge imaginable.
They've built a pretty impressive ecosystem, and it's constantly evolving with new services and features being released all the time.
It's a lot to take in, but I honestly feel much more equipped to navigate the world of AWS data now. I've gone from feeling overwhelmed to feeling empowered.
That's what we like to hear.
To all our listeners out there who are ready to take the plunge, don't be afraid to get your hands dirty and start experimenting. The cloud is your oyster, and the possibilities are truly limitless.
Couldn't have said it better myself. And remember, AWS offers a free tier, so you can try out a lot of these services without breaking the bank.
That's a great reminder. Free tier is your friend. Well, on that note, I think we've reached the end of our AWS deep dive. Thanks for joining us, and happy cloud computing, everyone.
Happy cloud computing.